Okay, we're going to introduce the ideas of domain and range. So you might want to take some notes as you're watching us as well. Pause it as needed.
Next up in the lesson is identifying the domain and the range by only looking at a graph. This can be a little bit challenging for students, so we want to pay attention here, and a lot of your assignment will be doing this. What I've got here is a gray box. I'm going to cover up the graph. Now on your notes, what you can do is just you can use another piece of paper or your hand. Basically the way this works is you cover up the whole thing. This will help us, trust me, this will really help you identify the domain and the range much easier. So what we're going to do is list the smallest domain value. Well, domain values are all of the x's. So you'll look at the very smallest x value by moving over and trying to figure out where is this left side of the graph, the furthest thing to the left. Ah, there it is. Okay, so it starts at -2. So you come over to your graph and we're going to do a bracket -2. Now, why did I do a bracket? Because it is including the -2. If this had been an open circle, I would do parentheses -2 instead because it would not include that point. A bracket includes the -2. Then I'm going to say comma, and then it continues until you get to, now I'm going to keep dragging this thing over and revealing the graph. How far over does it go? It keeps going and going and going and going, and then finally it does not stop. It just keeps going forever, and so it goes off to infinity. So then I come right over here and say infinity. Okay, that was pretty bad. Now, infinity is always with a parenthesis. It does not ever have a bracket because we can never actually get to infinity. It's a number that just keeps going forever and ever. So we don't include infinity. We just say parentheses infinity. That is the domain using what's called interval notation. Now, here's an inequality notation, and that's where we are just going to say, let me write it out here and I'll explain it. X is greater than or equal to -2. This is inequality notation where we use a less than symbol or a greater than symbol, and we say all of the x values that are from -2 on up. That's what this statement means. Okay, so these two things are exactly equivalent. It just depends on the directions of the problem, if it wants interval, if it wants inequality, or if it wants both. Now, all that work was just for identifying the domain. So now,
I would pause here for a second. Notice that the arrow here looks like a greater than sign. So if you're going off in this direction, you would say that x is greater than or equal to -2. I actually had a student share that idea with me. This looks like an arrow pointing to the right. This is an arrow pointing to the right. If that helps you remember, go for it.
go back and identify what the range is. So we're going to go down here, cover this whole thing up again, and then we think, all right, range. Range are y values from the top and the bottom. So let's start with the smallest range. The smallest is going to be on the bottom. So we start moving this thing up, and there it is. So what's the smallest y value? It is a 3. So we're starting, let's go back to we're starting with interval notation. We go bracket 3, comma, and then you keep moving it up and up. And how far up does it go? Well, this is an arrow that really goes up forever and ever and ever. And so this one also goes on for infinity. And we do a parenthesis. Now, the trick with the inequality is because we're doing range, we have to use a y value. So it's all the y values that are greater than or equal to, that are bigger than this y value. So it's greater than or equal to 3. All right, there's our first problem on those. Let's try another one. We're going to do the exact same thing with number 4. So either use another piece of paper or use your hand, and we will cover up that graph. Now, to identify the domain, the smallest domain value, we will move this thing. Let's start dragging it, and we look for the farthest thing on the left, which in this case right there, it is a -2. Now, it doesn't have a filled-in circle, but on all of our graphs, we can assume that it is filled in right there, that it's actually touching -2. So we're going to say bracket -2, comma, and how far does it go? It keeps going to the right. It keeps going. So we're only looking at x values, and the x values keep going forever and ever and ever and ever off to the right. So it's just like example number 3, and this one goes to infinity. There we go. All right, how about the inequality? This one again is all of the x values that are greater than or equal to -2, just like the first problem that we did, or excuse me, the last problem we did. All right, range. Now we cover it up again, so cover it up with your hand or another piece of paper, and we're going to slowly reveal from the smallest range value, which would be on the bottom. So we start revealing, and then look here. What is the smallest range? There's an arrow here that it keeps going forever and ever. Therefore, the smallest range is -infinity, comma. Now, how far up does it go? It keeps going and going and going and going, and it never stops. See, so the y values, if you notice, there's never a break in any y values. It keeps going forever. Therefore, we say it goes to +infinity.
So now the arrows really appear to make it look like it's going forever and ever and ever to the right, but it is actually going, in this situation, forever and ever lower and forever and ever higher. Not very steeply or anything, but it is getting lower forever and higher forever as you go to the right. So that's why we're saying from a y perspective, from a range perspective, it's going to get infinitely low and infinitely high if we extended this graph, if we zoomed out on it.
Close parenthesis. Okay, well, now how do you say this with inequality notation? You don't really do it like this. What you say is all real numbers. Now, all real numbers just means everything, but there's a shortcut to writing all real numbers, which is nice. It's this symbol right here. It looks like an R with two little lines on it. So it's an R with two lines. This stands for all real numbers. That can be placed right here as well if you want to just write it like that, all real numbers, instead of having to handwrite it all out. It means the same thing. So these two things are equivalent. Okay, number 5. So let's try number 5 on your own. You're going to pause this video, try this one, see if you can get the same answers as I do. And just so you know, this red dashed line, that is just a little an asymptote to help you understand that the line is just going to gradually get closer and closer to that line. Never actually is going to touch it, though, on this example. And there's your answer to number 5. Let me show you how we do this one. It's a little bit more complicated than the ones we had before. So let's start off with domain by covering this up. Again, if you already have these answers and you know it's correct, if you want to skip ahead to the last problem, number 6, then you can do so. If you need some help doing this one, let me show you how it works. So as we start revealing the left side of the graph, the domain, the farthest one on the left, is actually -infinity because it keeps going forever and ever. That's why I put a -infinity right here. Then as we keep scrolling along, and we reveal, it stops once we get to the number 4. So the x values, we go off to -infinity and come up here to the number 4, and it stops. But because it's an open circle, I put a parenthesis at the end. So -infinity to 4. And that's the same thing as all of the x values that are less than 4. Not less than or equal to, just less than 4 in this case.
Notice again, look, this is a less than sign. The arrow here looks like a less than sign. Okay? The open circle, basically, it looks like a hole. It is a hole. There's no point at 4. There's a hole there. But you go up to 4, like 3.99999, close to 4. So you can't just say, I'm going to stop at 3, because everything infinitesimally close to 4, but not including 4, is included.
Because it's open. All right, now let's do the range. So the range, you start revealing the smallest range value. The ranges are the y, so you start on the bottom. And then you can see here it starts at -2. We assume with graphs that it actually touches that point, so we're going to say it's at -2 with a bracket. And then it keeps going. Now this is where it gets confusing for kids. They want to say it stops here at this value of -1, but it does not stop here because it's included there. So if you see, it's continuous this whole time. It never breaks of y values. Think of it like this. If I, as you're coming up here, right there at that point, it may not exist there, but it does on the left side, so you have to include it until you get to a y value of 3, which is the asymptote. So -2 to 3. And then the way you write the inequality is that it's the y values that are in between -2 and 3. All right, that was a lot.
Now, do you see why we are not including 3? We're using a parenthesis here because this asymptote tells us you're getting really close to 3, but it will actually never touch it. It'll look like it's touching it because it's just like a sliver of air between the graph and the asymptote. It can never actually reach 3.
pretty quick. You might have to rewatch that part and rewind if you didn't understand this number 5. We're going to go on and do the last problem, number 6.